Alright class, hope you guys are enjoying Monday off. I'm sitting here making a video for you, so I hope you appreciate that. So today what we're going to talk about is solving quadratics by factoring. Now, the whole reason why we've been factoring these last couple days is so that we can solve equations. That's the whole purpose of it, is to make things simpler for us and so we can solve our equations. Okay. Now, number one is important on this note sheet because a lot of people have a tendency of just dividing an x out. You should never, ever, 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 ever divide out by an x. When you do that, you turn it from a quadratic to a linear equation, and you only get one solution. If you have a quadratic, you should be getting two solutions. So instead, we're going to factor out our GCF like we've been doing. I'm going to take a 4x out, and I'm left with x minus 3. Now, in order for this to equal 0, this piece can equal 0, the first piece, or this piece can equal 0. That's called ZPP, zero product property. So all you have to do is set each piece equal to 0 to give us our two solutions. 4x is equal to 0, which means that x is equal to 0. There's one solution. Or I can say x minus 3 is going to equal 0, which means x is equal to 3. Again, notice how I got two solutions, one of them being 0. If you would have divided out by x first and said 4x minus 12 equals 0, you would have only gotten the one solution. So do not do that. You can, however, divide by numbers. So let's look at this next one. I want to solve for x squared. This one, it says solve by factoring. You can do that, or you can take the square root, but let's solve by factoring actually here. So we have 3x squared minus 75. In order to factor, we need to get it equal to 0. Pull out a 3. And hopefully you guys realize that this is the difference of two squares. And now you can set each piece equal to 0. And the 3 here does not matter. This will not give us any solution. We can divide by 3 and it's gone. It doesn't matter. So we have x plus 5 equals 0, x minus 5 equals 0, which means x equals plus or minus 5. Those are my two solutions for this problem. Plus or minus 5 will work. For this next problem, we have to move everything over to one side. Again, we want to get everything equal to 0. And this actually turns out to be a perfect square trinomial. 1 squared is 1, or the square root of 1 is 1. The square root of 9x squared is 3x. So I'm going to just try this to see if that is it. So I'm going to just do some quick mental math. 3x times 3x is 9x squared. 3x times 1 plus 3x times 1 is 6x. And then 1 times 1 is 1. So that is correct. So basically, we just have to set this piece equal to 0. 3x plus 1 is equal to 0, so x should be negative 1/3. Now, some of you guys might be saying, wait a minute, we only got one solution here, not two. Yes, that is true. Sometimes the 0 is a solution twice. If you think of a parabola when you're graphing it, if it's a solution, if you have two answers, the parabola will go through here and here. If you have one solution, the parabola barely touches at the vertex, and that is one solution, and that is a double 0, or it's a 0 that happens twice, which makes it bounce right back up off of it. So there are cases where you will get one answer, but that will be your vertex of your parabola then. Okay, now let's do 4. And again, if you guys feel comfortable doing this, why don't you pause the video and try a couple on your own to see what's going on. So we get 14x squared plus 2x minus 12. I notice the first thing I can do is take out a 2. And then I have to factor this. Now this can be Batman again. Negative 42. To get a negative 42, what do we got? Well, 7 and 6 would do that, right? So it actually turns out to be 7 and 6. I'm going to do positive 7x minus 6x minus 7x squared. Basically, I just did Batman. real fast. Okay, so anyway, again, this should equal the middle there. So what I get is 7x times x plus 1 and negative 6 times x plus 1. So my answer here is 2 times 7x minus 6 and x plus 1 equals 0. Set both pieces equal to 0 again. Again, the 2 does not matter here. So we'll get x is equal to positive 6/7 or negative 1. Those are my two solutions by setting both those pieces equal to 0. So, last one for this section. Before we can do anything, we actually have to multiply all this out and figure out what we have here. So x plus 4. Again, if you guys write down x squared plus 16, you are wrong. You are very wrong, and it's going to ruin the problem every single time. You cannot just say, oh, I'm squaring the x and I'm squaring the 4. You have to FOIL this out. Distribute this out. This should turn into x squared plus 8x plus 16 on this side. This side is 2x plus 16 minus x squared. Move everything over to get it equal to 0, which I'll do now. You get 2x squared when you add the x squared. Subtract 2x, so you subtract 2x and you get positive 6x. Subtract 16 and you get 0. This is another case where we cannot now divide by 0. We have to now take our GCF. So my GCF would be 2x, and I get x plus 3. And set each piece equal to 0. So my answer should be x is equal to 0 and negative 3. Okay? Very similar to the first one, actually. Very similar to the first one. Alright, so intercept form. Basically, the x-intercepts when y is 0 are your answers. We're setting these all equal to 0. Notice how all these problems are equal to 0. That's saying our y is equal to 0, because usually quadratics are y equals. So if I go back to this graph up here, intercept form is basically just factoring it. Factor it and then set it equal to 0. And then give the zeros. So intercept form would be, I want this equal to 0. But actually, I want the whole equation. So what I want to do actually is set it equal to y. We're not solving it, we're just writing it as something else. Why isn't it deleting? There it goes. So intercept form is going to be equal to y because I want the whole thing. Now, let's factor this. Again, we can use Batman, or I should say splitting this middle term, which is negative 7. I get negative 18. Multiply to a negative 18, add to negative 7. I get a negative 9x and a positive 2x, and that splits that negative 7x up for me. Okay? Factor out a common factor. So my answer is y is equal to y is equal to 3x plus 2 and x minus 3. This is intercept form, because what does this do now? I can easily find my x-intercepts, the zeros. Those are called zeros. You'll also hear them as roots. Whenever I say the word root or 0 or the x-intercept, those are all the same thing. So now I'm going to find, so this is my answer for the intercept form, and now I'm going to find my zeros. Again, set each piece equal to 0. You should get the zeros are the coordinates. X is 3, and then y is 0. And the other one is, when I solve this piece for x, when I set it equal to 0, you should get negative 2/3, 0. Those are my coordinates on the graph where it hits the axis, and those are the intercepts. Okay? Alright, so last step, or next one, just factor this. You guys should be able to see that this is a perfect square trinomial. X plus 5 quantity square will give us this middle term, because 5 times x plus 5 times x is 10x, 5 times 5 is 25, x times x is x squared. So this one just factors to y is equal to the quantity x plus 5 quantity squared, and that is intercept form. So I'm already done with that. Now, this is another case where if you solve this, you're only going to get 1, 0. My 0 will be when x is negative 5. So it's the point negative 5, 0. And if I do that graphically, again, what happens is that actually is the vertex of my parabola because it is touching it once. And we're going to talk about this more in the next lesson. I know we're out of order kind of a little bit, but you'll see that as we do more with that. So, and now I'm done with those two problems. So all I have left is this one word problem. A yearbook editor is designing a page layout. Outside dimensions are 9 by 12. So, there are many ways to do this problem. However, I'm showing you how to do one way. There is a 9 by 12 page, so 9 inches by 12 inches. And then it says the white border around the rectangular printed picture on the page is twice as wide on its sides as it is on the top and bottom. So, there's some other border, the picture's here, and this white border is twice as big on the side. So I'm going to call this 2x, this border, and this x. And then it says the area of this picture in here, this is the picture, the area of this picture is 50. What are the dimensions of the picture? Well, hopefully you guys see that this length right here, the width of the picture, is 9 inches minus the 2x minus the 2x, because there's a 2x on either side that we're taking away. So we know that the length, or the width I should say, is 9 minus 4x, not 2x. The other direction, I have this 12 inches long, but I have to take away these two x's so I can get this actual length. So that length is 12 minus 2x. And when I multiply this side by this side, it's a rectangle, you should get the area of that picture. And we know that that area is 50. Okay? So, I am going to now multiply this out and factor it, just like another problem we were doing. So, 9 times 12 is 108. 4x times, let's do 9 times negative 2x is negative 18x. Negative 4x times 12 is a minus 48x. And then finally we get a plus 8x squared equals 50. Move everything to the, let's write it in correct order, move everything over. I get my 8x squared. This becomes what, a negative 66x. And then I have 108 but minus 50. So that becomes 58. Equals 0. I just moved the 50 over and took it away from the 108 and wrote it in the correct order. So let's pull out a GCF first, because that makes life a lot easier. And the only thing you can really pull out of here is a 2, though. So we get 4x squared minus 33x plus 29. Okay? And then you guys should be able to factor this. So one of the things you can come up with, again, you can do guess and check, or you can do Batman if you want to know for sure. But if you multiply these, you get 116. So you need numbers that multiply to 116 and add to negative 33. Well, 29 and 4 add to negative 33 if they're both negative. So negative 29x, negative 4x. And then this becomes 4x squared. Okay, so now I am just going to finish this off. Again, this 2 really doesn't matter when we're solving. It only matters if there was an x out there, which there is not right now. So I'm going to group this. I'm going to say that I could take a x out, and I get 4x minus 29. And I could pull a negative 1 out to make it 4x minus 29. Remember, you want to, for grouping, get those equal. So my final answer is x minus 1 and 4x minus 29 equals 0. So x can be two things here. X can equal 1 inch, or x can equal, if you do 29 over 4, it's about 7.25 inches. But let's look at the picture now. Yeah, those are both positive numbers, but do those both make sense? If x is 7.25 and I put it in here, that's saying that this border is about 14.5 inches, which is impossible because the whole page length is 9. So really, you have to look at your problem and go, there's no way that that x can be 7.25 inches. So we only want the 1 inch. Okay, so what are the dimensions of our picture then? Well, our dimensions of our picture, if we look back at our original two pieces in the blue and red up here, 9 minus 4 times 1 and 12 minus 2 times 1. So my dimensions are 5 inches by 10 inches, which makes sense because if you multiply those two together, you get 50. But we use factoring to make sure that that was correct. All right, and that is it for today.